Welcome. In this video, we're going to wrap up our discussion of Unit 1, Activity 6. Company A started in 2010 with a revenue of $15,000. Every year after, they had a steady revenue increase of $4,000. Company B was founded in 2010 and had a revenue of $10,000 its first year. Thereafter, Company B increased its revenue by $6,000 per year. Part A. In order to solve a system of equations, the variable definitions for each equation must be identical. Define the variables for each company. So we have two companies. Company A is going to have an X value and a Y value, and Company B is also going to have an X value and a Y value. Now, the easiest choice to make is for the dependent variables, that's the Y values, and we're distinguishing these by these subscripts of A or B depending on the company. So the dependent variable is the revenue. The revenue is dependent on the year. So let Y sub A represent the revenue of Company A in thousands of dollars. Similarly, Y sub B is going to represent the revenue of Company B in thousands of dollars. Now let's talk about the independent variables, that is our X's. We have two possible years to choose from. We know both of these are going to be years since blank. Company A was founded in 2010 and Company B was founded in 2012. Now it would be a mistake to say this is years since 2010 and this is years since 2012. We need to define our variables so that we pick one year or the other. So I'm going to go ahead and pick 2010. You could have picked 2012 as well and represented the year 2010 with an X equals -2, but to just keep it simple without having to represent any of the starting years with a negative, I decided to just have both variables represent years since 2010. Part B, let's create a table of data for each company, and let's remember the variable definitions from Part A. Company A started with a revenue of $15,000, and Company A was started in the year 2000, so in 2000, 0 years have elapsed. Now let's start with Company B here, and I mislabeled this. This should be YA. Company B began with a revenue of $10,000. And now they were founded in 2012. So what is this X sub B going to be? Remember, this is years since 2010, and they were founded in 2012 with a revenue of $10,000. So in 2012, 2 years had passed in 2010, so this is a 2. Each subsequent year, so let's go years 1, 2, 3. And here we're going to go years 3, 4, and 5. So each subsequent year, Company A increased its revenue by $4,000 each year. So in year 1, if they had So in year 2010, when they were founded, they had a revenue of $15,000. That means in the second year, they had 15 plus 4 equals $19,000 revenue. Similarly, for Company B, they were founded in 2012 with a revenue of $10,000 and increased their revenue by $6,000 each year. So for the second year the company was around, which is 2013, they would have 10 plus 6 equals $16,000 in revenue. Please pause your video now and see if you can complete 2 spots for Company A and 2 spots for Company B. And again, I can't force anyone to pause their videos, but it is in your best interest to pause these videos and try these independently. Your table should look like mine. For company A, you should have filled in these last two values on your table, and for company B, you should have filled in these last two portions. Question 7 continued. Let's create equations for each company. And so let's recall, company A started in 2010, and we said X is the years since 2010, and they had a revenue of $15,000. Company B started in 2012 with a revenue of $10,000. So here we have our points for company A and B. Additionally, we're given slopes for each one. We're told the slope for company A is 4, since each year their revenue increases by $4,000. We're also told the slope for company B is 6, since each year its revenue increases by $6,000. So for company A, our equation is a lot easier to find. We have this representation of a linear equation. This is in slope-intercept form. I can tell the x-intercept, the y-intercept, the b here is 15, because when x equals 0, we have our y-intercept, and in this case it's 15. Additionally, I know the slope is 4, because I was given that. Now for company B, we have to work a little bit harder. For company B, let's use our point-slope form of a linear equation. And this tells us that this line here will pass through the point x0, y0 with a slope of m. And we have a point here. We're given this point 2, 10, and our slope is 6. So filling in the blanks, we have y minus 10 equals 6 times x minus 2. Y minus 10 equals 6x minus 12. Adding 10 to both sides, we end up with y equals 6x minus 2. So for company A, I'm going to call this A sub x equals 4x plus 15. And for company B, I'm going to call it B sub x equals 6x minus 2. Part D, let's algebraically solve for when the companies have the same revenue. So to do that, let's set these two equations equal to each other. So 4x plus 15 equals 6x minus 2. Now we can solve this by starting, let's subtract 4x from both sides. Then add 2 to both sides. And then dividing both sides by 2 leaves us with x equals 17 halves. And that's the same thing as 8.5. Now we can't just leave our answer like this. Let's interpret it. What does 8.5 actually tell us? Well, if you remember, x represents the number of years since 2010. And x for company A and company B had the same representation, so I'm just using a general x here. So since x represents the number of years since 2010, when x equals 8.5, we have 2010 plus 8.5 equals 2018.5, so midway through 2018. So midway through 2018, the two companies had the same revenue. Let's use technology to graph these two equations from part C and find their intersection point. So remember, our two equations were A of x equals 4x plus 15, and we had B of x equals 6x minus 2. And I'm going to use GeoGebra to graph both of these. So here in GeoGebra, start by typing in y equals 4x plus 15. And that's company A. And we can actually rename that by tapping the ... settings. And let's call this A to match up with company A. So there it is, company A. Now company B, let's type in y equals 6x minus 2. And in keeping with precedent, I'm also going to rename this one by tapping the ... going to settings, tapping here on the first line where it actually says line, erasing that F and typing in the letter B. Additionally, I'm going to change the color to orange. And then for company A, I'm going to change the color to blue. Now let's see if we have the same intersection we found in our previous answer. In our previous question, we noticed that x equals 8.5. So that is midway through 2018, they had about the same revenue. So hitting the little downward arrow or downward symbol in the purple bar hides that, and now I'm going to put my index finger on 5, my thumb on -5, and pinch my fingers inward, and that's a nicer view. I'm going to take just my index finger, put it on the 3, and push left or swipe towards the left, and that's really nice. Now I'm going to put my thumb at 0, my index finger at 6, and bring my fingers together to pinch this a little more. And since it's a little too short, now I'm going to stretch it by putting my index finger at 20, my thumb at -20, pulling upward, and then doing the same between 5 and 10 until I get this picture here. And I want to know if this intersection matches up with my answer. Actually, here we go. I've adjusted it a little further, and as you can see, this intersection point lies somewhere, ooh, that gave it away, between 8 and 10. In fact, it is at 8.5 as we figured out algebraically. Let's go ahead and reproduce our sketch now. And this sketch should give you a great idea of what I'm actually looking for when I grade these. I have an x-axis that is clearly scaled, so each of these dashes represents 2 years, since I go from 2, 4, 6, 8 to 10. And this is labeled as years since 2010. The vertical axis, each of these little hash marks represents $10,000, since I can go 10, 20, 30, 40, all the way to $50,000, and I have a label that says revenue in thousands of dollars. And then I made an effort to keep my scale pretty evenly spaced. It's a little bit harder for me to do on my iPad, but on your piece of paper, you should be using a ruler or graph paper to ensure your scale is appropriate. Okay, now that that's done, let's make a quick sketch of our graph. So I know they intersect at 8.5. So here's 8, so about here, and 49. So they intersect kind of up here. Now, what about our intercepts? Well, the y-intercept for A is in blue, and that is at 15. So I can go 10, 20, so that'd be this middle point, and I'll draw a blue dot. And now I can connect this blue dot with the black dot. Now I can connect the blue dot with the black dot. Let's do the same thing for B. The intersection for B is at -2, and since this here represents 10 units, 2 is probably here, so -2 is probably really close to the x-axis, so I'll just sketch it there. Then I'm going to connect this orange dot with this black dot. And there you are. There are our two equations sketched for x plus 15. And they intersect right at about 8.5 here in black. And then here in orange, we have 6x minus 2. Now for part F, how does our answer in part E verify our answer from part D? If our answers did not match up, we'd have to check our work for errors and try again. So since our answer matches up and they do intersect at about 8.5, 49, then we know our work is correct. And this is a great trick, since when you're sketching your graph, sometimes the axis can be tricky to read. Labeling intersection points is a fantastic habit to get into. I hope this video was helpful.